Pluto used to be classified as a major planet, but later it was reclassified as a dwarf planet, a category for celestial objects that are too big to be asteroids, but too small to be considered full-fledged planets. Recently, scientists have turned their attention to one of Pluto's moons, speculating that it might qualify as part of a double planet system located in the distant Kuiper Belt, a vast region beyond Neptune filled with icy objects. Pluto is one of many small, frozen bodies known as Kuiper Belt objects. These remnants from the early solar system hold clues about its formation and are also where many comets originate. Although small, Pluto is still remarkable. It's about 1,400 miles wide, roughly half the size of the United States, and even smaller than our moon. Pluto's thin atmosphere is made up of nitrogen, methane, and carbon monoxide, and its surface is extremely cold, with temperatures averaging around -390 degrees Fahrenheit. It follows an elliptical orbit around the Sun, taking about 250 Earth years to complete one Pluto year. Notably, Pluto rotates in retrograde, spinning on its side due to its tilted axis. If you were on Pluto, you'd see icy mountains, valleys, plains, and craters under a dim sun that would cast a perpetual twilight glow. Surprisingly colorful, Pluto's surface shows hues of pale blues, yellows, oranges, and deep reds. One of its most charming features is the heart-shaped region, known as Tomball Regio. Discovered in the 1930s, Pluto was initially classified as the 9th planet. However, as scientists explored the Kuiper Belt, they found several more small planets like Pluto, such as Eris, Haumea, and Makemake, that shared similar characteristics. This led to the creation of the dwarf planet category, where Pluto found a new classification alongside other similar objects. Dwarf planets differ from major planets mainly in size and mass. Pluto has 5 known moons: Styx, Nix, Kerberos, Hydra, and the most intriguing of all, Charon. Charon is about half the size of Pluto, and together they form an unusual pairing that might even qualify as a double planet system. The center of mass between Pluto and Charon lies outside of Pluto, meaning they orbit each other rather than Charon simply orbiting Pluto. Binary objects are common in the universe, but double planets are rare, and we haven't found a confirmed double dwarf planet system yet. If Charon is eventually classified as a dwarf planet, it would create the first binary dwarf planet system. Another candidate for a double dwarf planet system is Eris and its moon, Dysnomia. The solar system also has other fascinating moons, some of which might even harbor life. Gravitational interactions with Saturn and another large moon, Dione, create tidal forces that keep Enceladus warm, potentially allowing for a subsurface ocean that could support microscopic life. Another life candidate is Titan, Saturn's largest moon. Titan, with temperatures around -290 degrees Fahrenheit, has lakes of liquid methane and ethane. Some scientists speculate that life forms on Titan or consume chemicals like acetylene or hydrogen. Evidence of missing hydrogen and acetylene on Titan's surface even hints that something might be eating these substances, suggesting the possibility of methane-based life. Neptune's moon Triton is yet another candidate. Triton has nitrogen geysers erupting from its icy surface, indicating warmth beneath, which might also mean liquid water and organic molecules exist there. Sending missions to these distant moons is challenging, with Voyager being the only spacecraft to visit some of these regions in 1989. Future missions would require advanced technology to travel beyond Mars and explore the outer solar system. Hopefully, in this century, we'll unlock more of the mysteries that the solar system holds